Hello class, and thank you for watching. In the first part of 3.5 transformation of functions, we're going to focus on vertical and horizontal shifts. So let's begin with vertical shift. Now a function, f be a function, let f be a function and c be any positive real number. The notation that y equals f of x plus c means that the graph of y equals f of x is going to be shifted upwards c units. So this plus c that we have right here is going to move down. If we're adding, we move it up, and if we're subtracting, we move it down. As you see in this examples right here. So let's say that this point here is at the x value of 1, but the y value is, let's say, 2. By adding this constant, whatever this constant is, let's say that we're adding 7, it's not going to be to scale here, okay, and this number that we're adding is 7, then the graph is going to move up 7 units. So right now, that y value is at 2, and it's going to move all the way up 7 units, making it a 9. So you see the y coordinate of this point of 0, 2 changes to the coordinate of 0, 9 as a result of adding 7 to the function f of x. And if we're moving downwards, it's simply going to subtract it. So we look at an example of this. We have two examples right here. Here we have the function, and we have f of x equals y. F of x is denoted by this function down here. So this is f of x right here. And we want to create this new function. In example 1a, we want to create the function g, which is going to equal to f of x minus 4. So the graph of g is going to have the exact same shape as f. However, it's simply going to be shifted down 4 units. So let's do that in blue. So moving this down 4. Continue moving the other points down 4. Let me use this. Let me just plot this point to this point right there. Let's move that point also down 4. Along with this one down 4, and the last one down 4. So you see we're moving them all down 4. Okay, so C minus 4 on all of them. And that's going to put them in those positions. And let me now put those dots in red and connect them again with the exact same shape. Okay, my arch came out a little bit wrong here. And then minus 4. Okay. So you see that the shape's the exact same value. And what I want you to pay very close attention to is this fact right here. Look at this. Okay. Let's say this point right here. This point has an x value of 0 and a y value of 3. When I move that point down 4, the x value is still the same, so I won't say new, but the new coordinate is 0 and the y coordinate is negative 1. See how this number changed from 3 to negative 1 is because subtracting 4 to that y coordinate is what causes this thing to move down. So if I do 3 minus 4, I end up again with this coordinate of negative 1 down there. Let me just write it a little bit nicer, negative 1. So you see we have that coordinate right there, 0, negative 1. So the same thing's going to happen if I move up. So in this next example, plus 3 is going to move it up 3 units. The graph is going to look exactly the same, but simply up 3 units. So I'm just going to trace this. I'm just going to get those points. Trace that and then move it. So here we go. Let's move it. Oh, hold on. I did not connect this last part right here. Okay, so let's move it all. Let's move it all 3 units. So 1, 2, 3. Okay, it's a little bit off to the right a little bit. Let me move it a little bit more to the left. I'm sorry, a little bit more to the right. There, look, there you go, much better. So you see, I moved it up 3. This right there is 3 distance up 3, up 3, up 3. Now this is the fascinating part. If I pay attention to these points, let's say this point right there, which is at 4, -1, okay? Look at it, this corresponding point. The x value is still 4, but the y value is now 2. So if I compare again what happened mathematically, this -1 plus 3 changed to 2. And if I look at all the other points, you'll see that the exact same happens to every single y value. They're simply adding this number or subtracting that number to the corresponding y values, and that's where the new coordinate is going to be. So you can use that if we need to do this, let's say in terms of graph, like in the next page. So let's use it now on tables. So if I'm doing it on a table, then this operation, like I said, is going to affect only the y values, because as you see again in the picture, you're just simply moving things upwards or downwards. So your y coordinate is going to change, but your x coordinate is going to be the same. So for example 2, let's say that the table represents this function f, and for part A, for question 2a here, we want to figure out what the table of g is if g equals to f of x minus 3. So this notation simply means that our x values are going to stay the same, but our y values will be subtracted by 3. So we're going to keep the numbers as 2, 4, 6, and 8 up there, and subtracting 3 to all of these y values. We're going to end up with -2, -0, +4, and +8. Not 11, 8. So 1 minus 3, 3 minus 3, 7 minus 3, and 11 minus 3. So for part B, for 2a, we ended up with that table. Now for 2b, we're going to create the table for g of x, which is f of x plus 5 more. So our x values are yet again going to stay the same, but our y values are going to increase by 5. Not from the previous one, but from the original y values that we have of f. So we want to get the f of x values, which is these values right here in yellow, and add 5 to those. So 1 plus 5, 3 plus 5, 7 plus 5, and 11 plus 5. And those are going to, this is going to be the table for g. Now down to to f of x plus c in order to move something to the left of what it originally is. So like in the picture that you see right here, in order to move it to the left right there, to this direction, in this direction, I need to add whatever this constant of c is to that. So more than likely this c is going to be some negative number. So I need to add that negative number in that direction in order for it to move there. Now, in order for it to move it to the right, the notation for that would be that g of x will equal to, y, I don't know why my g, y will equal to f of x minus c. So in order to move it to the right, I need this value of c to be positive, okay? But to show that we're moving to the right, I need to subtract that positive value. And we're doing the opposite operation in order to move it to those corresponding sides. Adding moves things to the left, while subtracting will move things to the right. So let's look at two examples of this. So here we have example 3a and 3b. So we have here the f of x is in the graph. So this is a picture of f of x. And we want to graph this function g in relation to f of x. So then the first notation we have is that g of x equals f of x minus 4. Well, since it's minus 4, it's not going to move things to the left. It's going to move the things in the opposite direction. So the graph of g is going to look the same as the graph of f. However, it's simply shifted to the right by 4 units. So we're going to get these points. Let me just trace over this. And we're going to get these points and move those points to the right 4 units. So 1, 2, 3, and 4. See, everything has been moved a total of 4 units to the right. Now look at this. This is very interesting. If I look at a point, let's say this point right there, where the x value is 3 and the y value is 2, okay, that point right there, and I compare it to where it moved, to this position right there, the x value is 7 and the y value is still 2. Look at the x values. Look how the x values change from a positive 3 to a positive 7. That's the result of doing the opposite of this operation right here. So this notation of x minus 4, because we're moving in the opposite direction, as a result, it's going to do the opposite operation to the x values. So here, this x minus 4 means that we're going to get our x value and add 4 to all of them. And if I look at all the other points that we have here and look at the x value, I'll see that all the x values are 4 units bigger right here in red. Now look at the next example. The next example has x plus 3. So x plus 3 is going to draw the same graph as f. However, it's going to shift it to the left this time. So if I get, again, these points, I'm just going to trace over them so the graph looks exactly the same and move them to the left 3 units, 1, 2, and 3 right there. This would be the graph of g. So to the left 3 units. And again, the cool thing about this, the amazing thing about this, is if you look at the point, let's say this point right here in green, which is 6, 4, and I compare it to its corresponding red position, which is this one right there. There we go. That position is at 3, 4. The x value is 3 and the y value is 4. Again, look how cool it is to see that the x values don't change. I'm sorry, the y values don't change, but the x values are decreased by that 3. So the notation that's indicated when we're doing a horizontal shift is the opposite operation of what's written. So x plus 3 really means that the x values are subtracted by 3 and not added by 3 as written in the expression. How cool is that? So let's look at the table of a horizontal shift. So we apply this concept again, like I mentioned, and simply do the opposite operation as indicated in the notation. We can identify again the horizontal shift to these functions. So in this example 4, we have part A, part B. I have the two notations. So for A, I have g is going to equal to f of x minus 3. So it's going to be the exact same graph of f, but simply shifted 3 units to the right. So this notation doesn't mean to subtract 3 since I need to move it to the right. That means I need to add 3. So all my x values are going to be increased by 3. So if my original x values are 2, 4, 6, and 8, the new ones would be 5, 7, 9, and 11. While the while the y values are going to be 1, 3, 7, and 11. Those don't change. So for part B, This again means this opposite situation. So since we have x plus 5, that means that we need to shift the graph to the left. So if that means that my x values are being subtracted by 3. So I'm going to look at the original x values, 2, 4, 6, and 8, and subtract 5 from them. So negative 3, negative 1, 1, and 3. I said 3 earlier, but I meant 5. We're subtracting by 5. And of course, your y values do not change. Those are still going to be 1, 3, 7, and 11. Now, let's say we're doing both combinations again with a graph. Well, all I have to do again is understand the direction that they're moving. Now, because they're horizontal and vertical shifts, it doesn't matter the order that you do stuff. I like to do things with x first and work my way out. So I'm going to first look at this, and then I'll worry about that. Okay? Well, the plus 7 doesn't mean to add 7. Remember, it means the opposite. So we're going to subtract 7 to all of our x's, which means we're going to move our graph 7 units to the left side. So 7 to the left. And the minus 3, well, we do exactly in that direction for the y values. And subtracting 3 to the y's, we'll move it down 3. Now, if I had a table of values instead of a graph right here, I would just do those operations to the x values, subtract 7 to the x values, and that will be my new set of x's. Subtract 3 from my y values, and that will be the new set of y's. And then do whatever I need to do with that information. Plug it in, graph it, and things like that. So like right here, since I already have the graph, I'm just going to simply shift my points in that direction. So I'm going to start by looking at this point here. I'm going to do it in green. I'm going to look at this point. 7 units to the right will mean I would subtract, where this point right here is 3, 6. I would subtract 7 to this x value, which is going to be negative 4. And minus 3 means to subtract 3 to the y value. So 6 minus 3 is 3. So 3 minus 7 is negative 4. And 6 minus 3 is 3. So that would put that position right there. And then I would just get any other point. Let's say this point right here, which is at 0, 9, and do the same operations. To shift it to the left, that subtracts 7 to the 0, so negative 7. And then minus 3 to move it down 3, I would subtract 3, so 6. So 7, negative 7 on the x, and 6 for the y. And that connects the left side. And I just do the same thing on the right side. Just find any point and move it the same direction. And my transformation will look like this. Now let's look at example B. So for example B, we have minus 7 and plus 3. So minus 7 is not going to really subtract 7. It's going to add 7. So it's going to move it to the right. And adding 3 on the outside, that affects the y value. And that's going to move it up. So 7 units to the right and 3 units up. So if I just simply count 1, 2, 3, 4, 5, 6, 7, and 3 up, that puts this position in blue to this position right here in green. And if I look at the x values of negative 4 and y value of negative 6, look how it correlates to this x value that we're located at, 3, negative 4. So in my original position of negative 4 plus 7, that equals to positive 3. And my original y coordinate of negative 6 plus 3 equals, oops, I did not count up enough. Because that's at negative 4, so I knew I messed up. There, this is much better. So negative 3, positive 3, that's the position I need to be in. That makes more sense because now when I do the math, it matches up. So let me start over. Negative 4 plus 7, not minus 7, but plus 7 is negative 3. And negative 6 plus 3 is positive 3. And I just do the same thing with any other point. Like for example, that point right there, 7 to the right and 3 up. That's going to put it in this location, and we'll just continue the pattern, and the graph will look like that. And now let's work backwards. Let's identify combined vertical and horizontal shifts. So we want to go backwards. Now I want to give you again the two functions f and g, and I want to write the formula of the transformation of g. So here we just simply need to identify our starting point, which is going to be f, to our lasting point g. So looking at any point and identifying its corresponding position after the shift will tell us whether we're adding or subtracting. So in this situation, for this graph, it's easy to identify the corresponding values because of its curvature. So if I look at this point here in blue and compare it to that curvature right there at green, that's a corresponding point. Using another point is possible, but it's probably not the easiest. Like example, this point right there, I would have to find it on this graph exactly where that is. So it could possibly be that one, or it could be another one somewhere else. But this one is the easiest, again, to identify because it's easy to tell that it matches to this one right here in red. So let's see what direction we're moving. We're obviously, first of all, moving to the right, okay? And we're moving down. So to the right and down. So let's start off with the equation for g. So that means that g of x will equal to f of x. Since we're moving to the right, that would be minus some number, and since we're moving it down, I'll close the parentheses, and then minus some other number out there. Well, since we're moving to the right of total 1, 2, 3, 4, 5, 6, 7, the inside number is going to be 7, and 1, 2, 3, 4, and 4 down, the outside number is going to be 4. So this is the function rule that transforms f into g. So, and now let's look at the next example. So on this one, same situation. I'm going to look at the vertex because again, it's easy to match up the vertex of this point with the one right here. And we're going to go from f to g. So here I want to know, how does this graph change to this graph there? So if we look at the vertices, well, the vertex is moving to the left and up to get to that location there. So since we're moving to the left, that's going to affect again the x value, and it's going to be f of x plus some number. Let me close the parentheses. And since we're moving up, that's going to add a number on the outside of that parentheses in order to shift it up. And now all we're going to do is just simply count. So this is 1, 2, 3, 4, 5. So 5 units to the left is plus 5. And 1, 2, 3, 4, 5, 6, 7 units up is plus 7 on the outside. So there is the rule for your transformation of this function f to this function g. Okay, well, that concludes the first part to 3.5, the transformations of functions. On the next video, we'll talk about reflections and dilations. Thank you for watching, and like always, I hope you have a great day. Goodbye.